Welcome to the new lesson of organic chemistry. This is lesson 2. In this lesson, we'll be looking at making the structures of organic compounds. Before we start making the structures, we should know that organic compounds are basically made up of carbon atoms, and the atomic number of carbon atom is 6. That means it has 6 electrons. If you divide these 6 electrons, we have 2 electrons in the first shell and we have 4 electrons in the valence shell. So overall, the carbon atom can make 4 covalent bonds because of the 4 electrons in the last shell. Always remember, each carbon atom can make 4 covalent bonds. These 4 covalent bonds can be made with other carbon atoms or with the hydrogen atoms. If carbon atoms make only single bonds with other carbon atoms, the family of the compound belongs to the family of organic compounds, which is called alkane family. Okay, so if we have all the single bonds between the carbon atoms in this manner, like for example we have this carbon atom over here, it makes a single bond with another carbon atom, and this carbon atom makes another single bond in this manner with another carbon atom, and the chain can be elongated as much as you want, but the bonds are all single. Okay, so you see single bond between the carbon atoms. If you look at the valencies, we have this carbon, the carbon had one valency over here and made a bond with the other valency of the carbon atoms, and this carbon atom is making one bond with this carbon atom. That means 2 of its valencies are used up. How many are left? 2 are left. This carbon used only one of its electron, and that is why 3 valence electrons or 3 valencies are left on this carbon. So in this manner you are going to look at the valencies and fill the remaining valencies with the help of hydrogen atoms. So if I fill the remaining valencies of the carbons with the hydrogen atom, it will look like somewhat like this. Okay, so you see there are single bonds. If the carbon atoms have only single bonds, the family is alkane family. Let's look at the second family of the organic compound, which is the alkene family. And in alkene family we have a double bond between the carbon atoms. So let's suppose we have this carbon atom, and as you know that each carbon has 4 valencies, but I showed you 3 over here. Why? Because I want to make a double bond between the carbon atoms. So if this carbon uses 2 of its valencies with this carbon, both of their carbons will have 2 valencies left. Okay, so 2 valencies used up, 2 are left for both the carbon atoms. If I add one more carbon over here, it's going to make a single bond next time, not the double bond. Always remember, if you have double bond once, you're not going to have the double bond again. You can have single bonds but not double bond again. You can have double bond once or twice in a chain, but not every time. Okay, so if I want to have another bond, if I want to put another bond with the carbon atom, I'm going to have a single bond, not the double bond. So over here we have a double bond and we have done single bond. So this family, this compound belongs to which family? It belongs to alkene family. Okay, the remaining valencies as usual will be filling with the hydrogen atoms, and the compound will look like this. Okay, let's look at the third possibility. We have another type of family which is called alkyne family. In an alkyne family we have triple bonds between the carbon atoms. So if 3 of the valencies are used for making a triple bond, only one valency will be left for this carbon, and one of this valency will be left over here. Okay, and if I want to add one more carbon over here, it will look like this. It will join like this, and as usual after the triple bond I'm going to have a single bond next time. Okay, if you fill the valencies, we'll be having hydrogen atoms over there. One thing to notice that we have no hydrogen atom on this carbon because all of its valencies are used up. 3 on this side, 1 on this side. Maximum are 4. 3 are used up on this side, 1 is used on this side, so no valencies left, and that's why this carbon has no hydrogen atom, and the compound is alkyne. And the compound belongs to which family? Alkyne family. Let's look at how we make the structures and the formulae of alkanes. We have alkanes, which is the first member and the most common member of the organic compounds. This is your SLO 11.3.1. We know that what do you have to do? We have to name the alkanes. Okay, we have to make the 10 members of the alkane family. We know that the general formula of alkane is CnH2n plus 2. What is N over here? N is the number of carbon atoms, okay? So for the first member, N will be 1. And for the first member, we'll be using this formula. We'll put the value for the value of N will be putting 1, okay? So it will look like this. For N, we have 1. H2, for N we have 1 plus 2 as usual, okay? So in the formula I just substitute the values. For N I put 1 for the first member, and the formula is CH4, okay? How are we going to name this? The naming is very simple. It is the first member, it has only one carbon atom. For one carbon we use meth, and because it is alkane, the suffix will be ane and the name will be methane. For the second member, I'm going to put the value of N. I'm going to substitute 2 for N, and that is why the formula will be C2H6. Once I solve this, the formula is C2H6. The name will be what? There are 2 carbon atoms. For 2 carbons, we use eth, and for alkane family, ane, the name will be ethane. For the third member, I'm going to put the value 3 for N, and the formula will be C3H8, and the name will be propane. And for the fourth member, I'm going to put the value 4. For all N values, I'm going to put with the value 4, and the formula will be C4H10 for the fourth member of alkane family, and the name is butane. Why butane? Because of 4 carbon we use but, and N for alkane family. So the name is butane. So I hope the naming is easy, and by using the same general formula, we are going to use all the members. We are going to make all the members of the alkane family. I have made 4 for you. You are going to make the rest others by yourself. So we have to use the same general formula for alkanes, and we have to make the 10 members of the alkane family, and we have also we also have to name them, okay? So I hope the lesson was easy, it was understandable. If you have any problem, you can ask me in the comment box. Meet you in the next lesson.